Hello folks, again a question of a different board, useful for our Cambridge people. So it belongs to 2015 May June, and paper is 1. It's concerned with the chapter of either forces. A 2.5 kg block is placed on a ramp. So this is the ramp. The block is released from a vertical height of 3.0 meters. An average frictional force of 6.0 Newton. Newton acts on the block as it travels along the ramp. So that means the frictional force here is this is Ff is equal to 6.0 Newton. The block travels a distance of 7.5 meter along the ramp. So we have to find what is the speed of the block at the bottom of the ramp. So in order to find that, we have to find the two forces here. So one of the forces is this one. So this force is mg sine of alpha. So where alpha is this angle. So the resultant force here will be equal to, so F resultant is equal to mg sine of alpha minus 6.0 Newton, which is the frictional force, and that is equal to mass into acceleration of the body down this plane surface. So I can denote this acceleration as AP. So this gives me m is 2.5, g is 9.81, and sine alpha is equal to perpendicular. This is perpendicular by hypotenuse. So it is 3.0 by 7.5 minus 6 equal to 2.5 into this AP. So this gives me this AP is equal to, so let me do the calculations here. So I have this 2.5 into 9.81 into 3 divided 7.5 equal to, and this minus 6 equal to 3.81. So this whole thing is 3.81, and when it is divided by this 2.5, then it becomes AP is equal to 1.524 meter per second square. So the acceleration of the body down this plane surface is this much. Now with the acceleration, I can find the velocity here. So the velocity here will be equal to v squared equal to u squared plus 2 AP into the distance traveled. The initial velocity is 0, since it says that the block is released. So this is 0. So we must have v equal to root of 2 AP into s. That's equal to 2 into AP is which we first just determined, 1.524, into s is from here to here, it is 7.5 meters. So when I do the calculations, it will become so this into 7.5 into 2 equal to, its root will be equal to 4.78. So it is 4.78 meter per second, and the answer closest to this value is choice number A. So choice number A is the correct answer, which is 4.7 meter per second.